Hi students, welcome back. This is plus 2 mathematics chapter 4 inverse trigonometric function exercise 4.5 and question number 1. Find the value of given if it is exist. So I take first question. First one, sine inverse of cos phi. Now we know very well cos phi value, right? So sine inverse of cos phi is nothing but minus 1. Now we are getting sine inverse of minus 1. We know very well sine pi by 2 which is equal to 1. Then sine minus pi by 2 it will be minus 1. Because sine of minus pi by 2 we can write minus sine pi by 2. Right? So sine pi by 2 it will be minus 1. So here we are taking minus pi by 2 only. So this sign goes to that side, sine inverse of minus 1. Therefore, sine inverse of minus 1 is nothing but minus pi by 2. So, first one is over. To the second one. Tan inverse of sine of minus pi by 2. First you will write the properties. Right? Sine of minus theta, it will be minus sine theta. Right? According to this, tan inverse of minus sine phi by 2. Here, we have to find out the value of sine phi by 2. Right? So, it will be right here 2 pi plus pi by 2. So we cross multiple this one. 2 2s are 4. So 4 pi plus pi nothing but pi by 2. Here 2 pi is nothing but 360 degree. So here 2 pi plus theta according to the rule AXTC, right? AXTC. This is 360 plus theta. Okay. Sine of 2 pi plus theta which is equal to sine theta, that is sine of 360 plus theta which is equal to sine theta. So according to this, tan inverse of minus this sine of 2 pi plus pi by 2 is nothing but sine pi by 2. So minus sine pi by 2. Now tan inverse of minus sine pi by 2 is nothing but minus 1. Now you know that tan pi by 4, tan pi by 4 which is equal to 1. The same way, tan of minus pi by 4 which is equal to minus tan pi by 4 which is equal to minus 1. So tan of minus pi by 4 which is equal to 1 and minus pi by 4 which is equal to this tan goes to the side, tan inverse of minus 1. So therefore tan inverse of minus 1 is nothing but minus pi by 4. Here tan inverse of minus 1 is nothing but minus pi by 4. So tan inverse of sine of minus pi by 2 is nothing but minus pi by 4. Now we want to go for the third one. So sine inverse of sine phi. Okay. Question number 3. Sine inverse of sine phi. We have property. We know that sine inverse of sine theta is equal to theta if the theta belongs to the interval of minus pi by 2 plus pi by 2. Now we want to check here phi not belongs to in the interval of minus pi by 2 plus pi by 2. How? We want to check it. Because sine inverse of sine theta is equal to theta. So sine inverse of sine phi, we want to take this phi. This phi want to belongs to minus pi by 2 plus pi by 2. I said here phi does not belongs to minus pi by 2 plus pi by 2. I asked reason to why. Right? So listen here. So we know very well pi is nothing but 22 divided by 7. It will be written like 3.14. Now divide by 2. What do you get? So 1 times Next 1.57. So 5 not belongs to in the interval of 1.57 comma plus 1.57. Isn't it? So 5 is the biggest number. Then this 5 not belongs to in the interval. But we want to find the value. Okay. So I added here 5 minus 2 pi. Now added minus 2 pi to this one. 5 minus 2 pi. What do you get here? Minus 2 pi means see pi means 3.14. Right? What about 2 pi? What multiple this one? So by 2. So 6.28. Now 5 minus 6.28. What do you get? Minus 1.28. Isn't it? This is the biggest one, this is the smallest one. So you want to subtract biggest to smallest. It will be minus 1.28. This minus 1.28 belongs to in the interval of 1.57 comma plus 1.57. Isn't it? So 5 not belongs to minus 5 by 2 plus 5 by 2. But 5 you are subtracting 2 pi from 5. It belongs to in the interval of pi by 2 plus 5 by 2. So therefore I added the question here, sine inverse of sine 5 which is equal to sine inverse of sine of, I added 2 pi, then subtracting 2 pi, then only the value doesn't change. So plus 2 pi minus 2 pi will be cancelled. I insert the bracket for especially 5 minus 2 pi. Now we are getting 2 pi plus theta. 2 pi is nothing but 360. So 360 plus theta. Sin 360 plus theta, sin theta. We have the result here. Sin 360 plus theta, which is equal to sin theta. That's sin inverse of sin of here pi minus 2 pi. Now we have to go for the result. Sin inverse of sin theta, which is equal to theta, if theta belongs to minus pi by 2 plus pi by 2. Now here sin inverse of sin of 5 minus 2 pi. This 5 minus 2 pi belongs to in the interval of minus pi by 2 plus pi by 2. It satisfies these conditions. Hence the sin and sin will be cancelled. We are getting 5 minus 2 pi. So what is the answer here? Sin inverse of sin 5 which is equal to 5 minus 2 pi. This is 4.5. Question number 2. Find the value of the expression in terms of x. So first question is sine of cos inverse of 1 minus x. So first question, sine of cos inverse of 1 minus x. So solution, I will take the cos inverse of 1 minus x is the first term. You know, inside the bracket I want assumption as theta. So cos inverse of 1 minus x which is equal to theta. That is our assumption. So take let is cos inverse of 1 minus x is equal to theta. Then what about 1 minus x? This cos inverse goes to that side, cos theta. So what is the question for us now? Sine of cos inverse of 1 minus x. It will be, you see, sine theta. Sine of, because cos inverse of 1 minus x is nothing but theta, you know. So sine of cos inverse of 1 minus x is nothing but sine theta. We know very well sine theta we can write square root of 1 minus cos square theta. Because in our formula sin square theta plus cos square theta which is equal to 1. So taking sin square theta, keeping sin square to left side and then go cos square theta right side, it will be 1 minus cos square theta. Then sin theta is nothing but square root of 1 minus cos square theta. According to this. So now square root of 1 minus cos theta value 1 minus x, but I have to find out cos square theta. So 1 minus x the whole square. So this is equal to, now I want to expand it 1 minus of using a minus b whole square formula, a square plus b square minus 2ab, so 2x. Now take it and go the minus inside. So sine of cos inverse of 1 minus x is equal to square root of 1 minus 1, then minus x square, then plus 2x. This minus and plus 1 will be cancelled, just alter it. So we get 2x minus x square. This is nothing but sine of cos inverse of 1 minus x. Now second one, cos of tan inverse of 3x minus 1. So first itself we have to take inside the bracket as theta. Now later, tan inverse of 3x minus 1 which is equal to theta. So what about 3x minus 1? This tan inverse goes to the side, should be tan theta. Now the tan theta we can write 3x minus 1 by 1 which is nothing but opposite side divided by adjacent side. Opposite side divided by adjacent side. Make assumption in the triangle like this. Okay, the right angle triangle, tan theta, theta will be acute angle. Then we can write tan theta is equal to opposite side divided by adjacent side. Now I want to find out hypotenuse side. So hypotenuse side square is equal to opposite side square plus adjacent side square. Then hypotenuse is nothing but square root of opposite side square. This is nothing but 3x minus 1 the whole square plus adjacent side square is nothing but 1 square. Now expanding this one, we get 9x square minus 6x plus 2. This is nothing but a hypotenuse, right? Now take the assumption here, cos of tan inverse of 3x minus 1 which is equal to cos theta. This because this tan inverse of 3x minus 1 we are assumed as theta. So cos of tan inverse of 3x minus 1 which is equal to cos theta. Here cos theta we can write adjacent divided by hypotenuse. So according to this, adjacent side is nothing but 1 and the hypotenuse side is nothing but root of 9x square minus 6x plus 2. Hence we can write 1 divided by root of 9x square minus 6x plus 2 which is nothing but cos of tan inverse of 3x minus 1. Okay, first one is the second problem, third one. So tan of sin inverse of x plus 1 by 2. Now as usual we want to take inside the bracket as theta. So sin inverse of x plus 1 by 2 which is equal to theta. Then x plus 1 by 2 which is nothing but sin theta. Now I want to find out cos theta first. So cos theta is nothing but square root of 1 minus sin square theta. So 1 minus here x plus 1 by 2 the whole square. So square root of 1 minus it will be like a plus b whole square format. So x square plus 1 by 4 plus x. Right? Second go inside the minus will come like minus x square minus 1 by 4 then minus x. So simplifying we get 1 minus 1 by 4. This is nothing but square root of 3 by 4 minus x square minus x. Take LCM. So 3 minus 4x square minus 4x whole divided by 4. Taking square root of this value. So numerator there is no change because we can't take square root. But denominator 4 taken square root as 2. This is nothing but cos theta. Now we have to see the question. Tan inverse of, therefore tan of sin inverse of x plus 1 by 2 which is equal to tan theta. Tan of sin inverse of x plus 1 by 2. This x sin inverse of x plus 1 by 2 they are shown as theta. So tan of sin inverse of x plus 1 by 2 is equal to tan theta. We know very well tan theta we can write sin theta divided by cos theta. Okay, what is the sin theta value here? X plus 1 by 2, you know. So x plus 1 by 2 divided by, what is the cos theta value? Square root of 3 minus 4x square minus 4x divided by 2. Taking cross multiply here, 2x plus 1. So 2x plus 1 divided by 2 divided by square root of 3 minus 4x square minus 4x divided by 2. This 2 will be cancelled. So we get the answer 2x plus 1 divided by square root of 3 minus 4x square minus 4x. This is required answer. Okay. This is exercise 4.5 question number 3. Find the value of sin inverse of cos of sin inverse of root 3 by 2. Now we have to find first sin inverse of root 3 by 2. Okay. Sine inverse of root 3 by 2, which is nothing but, we know very well, sine 60 degree. Sine 60 degree is equal to root 3 by 2. Sine 60 means nothing but pi by 3. This sine goes to that side, sine inverse of root 3 by 2. So, sine inverse of root 3 by 2, which is nothing but 5 by 2. Pi by 3. Therefore, sine inverse of cos of sine inverse of root 3 by 2, which is equal to sine inverse of cos of pi by 3. Now, sine inverse of cos pi by 3 is nothing but 1 by 2. Now, sine inverse of 1 by 2 is nothing but pi by 6. So, we can write simple method like this one. Okay. Next one, cot of sine inverse of 3 by 5 plus sine inverse of 4 by 5. First, you want to take only this value as theta. So, sine inverse of 3 by 5 which is equal to theta. Next, 3 by 5 which is equal to sine theta. Sine is goes to that side, sine theta. Now, you want to find the cos theta. So, cos theta is nothing but square root of 1 minus sine square theta. This is nothing but the root of 1 minus 9 divided by 25. So, which is nothing but 25 minus 9 divided by 25. 25 minus 9, nothing but 16. 16 by 25. So, 4 divided by 5. Then theta is equal to cos inverse of 4 by 5. So, sine inverse of 3 by 5, which is equal to cos inverse of 4 by 5. Now, the question, cot of sine inverse of 3 by 5 plus sine inverse of 4 by 5, which is equal to cot of cos inverse of 4 by 5 plus sine inverse of 4 by 5, which is nothing but cot pi by 2. So, cot pi by 2 is nothing but 0. Here, this is the result here, cos inverse of x plus sine inverse of x, which is equal to pi by 2. This is the result property of cos inverse of x plus sine inverse of x. Here, the value already will be same, means it should be pi by 2. Here, cos inverse of 4 by 5 and the sine inverse of 4 by 5. So, 4 by 5 are same. So, the cos inverse of x plus sine inverse of x becomes pi by 2. Like this property we want to use. But cot pi by 2, nothing but 0. Okay? This is exercise number 4.5. Question number 3 and subdivision also 3. Find the value of tan of sine inverse of 3 by 5 plus cot inverse of 3 by 2. I take first sine inverse of 3 by 5, which is equal to alpha, and cot inverse of 3 by 2, which is equal to beta. Now, here 3 by 5 is equal to, the sine inverse goes to that side, sine alpha. Now, I want to find out the cos alpha here. Cos alpha is nothing but square root of 1 minus sine square alpha, which is equal to 1 minus sine alpha is nothing but 3 by 5, sine square alpha nothing but 9 divided by 25. Cross multiply this one, 25 minus 9, which is equal to 16 divided by 25. Taking square root, we get 4 divided by 5. So, cos alpha, which is equal to 4 by 5. What about tan alpha? Tan alpha is nothing but sin alpha divided by cos alpha, which is nothing but sin alpha is equal to 3 by 5 and cos alpha nothing but 4 divided by 5. 5 will be cancelled. So, tan alpha is equal to 3 by 4. Here, cot inverse of 3 by 2 is equal to beta. What about 3 by 2? Nothing but cot beta. Now taking reciprocals, so 2 by 3. Here 1 divided by cot beta. So 1 by cot beta is nothing but tan beta, which is equal to 2 divided by 3. Now, here a small question arises here. Why we want to find tan alpha and tan beta? Why we want to change sin alpha in terms of tan alpha and the cot inverse of something into tan beta? Now, let us assumption sin inverse of 3 by 5 is equal to alpha, cot inverse of 3 by 2 is equal to beta, isn't it? Therefore, this question becomes tan of alpha plus beta. Now, we know very well the formula tan of alpha plus beta is nothing but tan alpha plus tan beta divided by 1 minus tan alpha into tan beta. So this purpose we are finding here sin inverse converted into tan alpha and the cot inverse converted into tan beta, right? Okay, so this is the purpose we are finding. We are changing, transforming sin inverse into tan and cot inverse into tan beta. Now let's see the question. I just need the results, but I want to use it now. Now tan of sin inverse of 3 by 5 plus cot inverse of 3 by 2, which is equal to tan of alpha plus beta, and which is equal to tan alpha plus tan beta divided by 1 minus tan alpha into tan beta. So tan alpha 3 by 4, tan beta 2 by 3, isn't it? So 3 by 4 plus 2 by 3 divided by 1 minus 3 by 4 into 2 by 3. Here 3 denominator 3 cancel. If you want to are 2, 2 2s are 4. Here you have to take cross multiple. 3 3s are 9, 4 2s are 8, divided by 4 3s are 12. Sorry, 12. 4 divided by 1 minus 1 by 2. In numerator 9 plus 8 17, so 17 divided by 12. In denominator 1 minus 1 by 2 is nothing but half. So 17 divided by 12, here 2 divided by 1 and it will be cancelled. So 17 divided by 6. Therefore tan of sin inverse of 3 by 5 plus cot inverse of 3 by 2, which is nothing but 17 divided by 6. This is exercise 4.5. Question number 4. Prove that tan inverse of 2 by 11 plus tan inverse of 7 divided by 24, which is equal to tan inverse of 1 by 2. So now solution. We have the result. Tan inverse of A plus tan inverse of B, which is equal to tan inverse of A plus B divided by 1 minus A into B. Therefore, tan inverse of 2 divided by 11 plus tan inverse of 7 divided by 24, which is equal to tan inverse of, what is the A value here? 2 by 11, so 2 by 11 plus 7 divided by 24 divided by 1 minus 2 divided by 11 into 7 divided by 24. Now tan inverse of, I will take a cross multiple. Okay, so 2 into 24, 48 plus 11 7s are 77 divided by 11 into 24. So you want to multiply 24 into 11. So 24 that is nothing but 264 divided by, so you want to cross multiply with this one. So 264 minus 2 7s are 14 divided by 264. So this 264 will be cancelled. So tan inverse of numerator not added, 48 plus 77, 8 plus 7 15, so 5 balance 1. So 4 plus 1 5, 5 plus 7 12, 125. 125 divided by 264 minus 14 is nothing but 250. So cancelling 125 table, so we get tan inverse of 1 divided by 2. So tan inverse of 2 by 11 plus tan inverse of 7 by 24, which is equal to tan inverse of 1 by 2. Hence proof. This is exercise 4.5. Question number 5. Prove that tan inverse of x plus tan inverse of y plus tan inverse of z is equal to tan inverse of x plus y plus z minus xyz divided by 1 minus xy minus yz minus zx. Now let's write tan inverse of x plus tan inverse of y plus tan inverse of z. I took last two, then it will be tan inverse of x plus tan inverse of, we have a formula, isn't it? Tan inverse of x plus tan inverse of b. So we can write y plus z divided by 1 minus yz. So addition of this plus means you want to write plus, okay? So tan inverse of y plus tan inverse of z means y plus z divided Now again we get tan inverse of x plus tan inverse of y by the formula. So adding this two, we get the tan inverse of x plus y plus z divided by 1 minus y z whole divided by 1 minus x into y plus z divided by 1 minus y z. So tan inverse of, now this one is cross multiple, x into 1 minus y z plus y plus z whole divided by 1 minus y z. Now again this one cross multiple, 1 minus y z minus x into y plus z divided by 1 minus y z. This 1 minus y z, this 1 minus y z will be cancelled. Then numerator 1 with this one, x1 sum x minus x y z, then plus 1 plus z divided by 1 minus y z. What multiple with minus x into y plus z, we get minus xy minus xz. Okay, so this is nothing but RX. Taking LHS, finally getting RX. So x plus y plus z minus xyz, you see x plus y plus z minus xyz, and denominator 1 minus xy minus yz minus xz the same way, 1 minus xy minus yz minus zx. Here should be altered but same value only. So LHS equal to RHS in school. Before we are completing this one, we want to take and write therefore like this. I calculate here itself. Therefore, tan inverse of x plus tan inverse of y plus tan inverse of z is equal to tan inverse of this one x. So you want to complete this one. LHS equal to RHS is okay, but before the completing this sums, you want to write a loss statement given question. It gets marks. Okay, so you want to complete this one means you get it full mark. Otherwise, you definitely will lose 1 mark. So this is a final step. Okay, thank you.